I'm Vijayakar. In this video, I'm going to explain about some technologies of in wireless network. First topic series. What are the protocols? What is the importance of a stand? What are the OSI 7 layers? What is the TCP/IP suite? And relationship between OSI 7 layers and TCP suite. Okay, let's go at the first topic. What are the protocols? Network communication occurs between entities in different systems. Therefore, two entities cannot simply send bit stream to each other and expect it to be understood. For making communication, the entities must agree on protocol. Protocol is the set of rules that control data communication. Protocol define what is communicated, how is communicated, and when is communicated. The key element of protocol are syntax, semantic, and timing. Syntax. The term syntax refers to the structure or format of data. Semantic. The word semantic refers to the meaning of each section of bit. Time. The term time refers to characteristics, when data should be sent and how fast they can be sent. Okay, next we are going to discuss what is the importance of standards. Standards. Standards are essential in creating, maintaining an open, competitive market for equipment manufacturers and guaranteeing national and international interoperabilities of data and telecommunication technologies and processes. Standards provide guidelines to manufacturers, vendors, governments, agencies, and other service providers to ensure the kind of interconnectivity necessary. Data communication standards fall into two categories: de facto standards that have not been provided and organized. De facto standards are often established originally by manufacturers who seeks to define the functionality of new product or technology. The jure. Those standards that have been legislated by the official recognition body. The jure is standard. The next topic is what are the OSI 7 layers? OSI 7 layers is Open System Interconnection. It's a reference model that describes how information from software application in one computer moves from physical medium to the software application in another computer. OSI consists of several layers, and each layer performs particular network functions. OSI model was developed in International Organization for Standardization ISO in 1984, and it is now considered as the architecture model for intercomputer communication. OSI model divided into whole tasks in seven small and manageable tasks. Okay, let's know about each layer function. First layer is application layer. At the very first of OSI reference model is type of layer. We find we find application layer which is implemented by network application. This application produces data which has to be transferred over the network. This layer also serves the window for application service to access the network and for displaying this receiving information to the user. Application layer is also called as desktop layer. The next layer is presentation layer. The presentation layer is also called the transport layer. The data from the application layer is extracted here and manipulated as per requirement format transmit over the network. The function of presentation layers are transaction, encrypt and decrypt, compression. The next layer is session layer. This layer is responsible for establishment of connection, maintenance of session, and authentication and also ensure security. The function of session layer are session establishment, maintenance and terminations, synchronization, dialect controller. The fourth layer of transport layer. The transport layer provides service to application layer and task service from the network layer. The data in transport layer, referred to as a segment, is responsive for the end-to-end delivery to the complete message. The transport layer also provides the acknowledgement of successful data transmitted and retransmitted the data if an error is found. Functions of transport layers are segmentation and resampling, service point addressing, and connectionless services. Fifth layer is network layer. Network layer works for transmission of from one host to other location in different network. It also takes care of packet of routing. Example, selection of the shortest path of transmitting the packet from the number of routers available. The sender and receiver IP address are placed in the header by the network layer. Function of this layer, routing and logical addressing. Sixth layer is data link layer. The data link layer is responsible for the node-to-node delivery for message. The main function of this layer to make sure the data transfer is error-free from one node to another node. Over the physical layer, when packet arrives in the network, it is responsible of DDL to transmit to the host using its MAC address. Data link layer is divided into two sublayers. Those are logical link layer, LLC, media access control, MAC. Functions of the data link layer are framing, physical addressing and error controlling, flow control and access control. 7 layer, the last layer, physical layer. Physical layer. The lowest layer of the OSI reference model is the physical layer. It is responsible for the actual physical connection between the device. The physical layer contains information in the form of the bit. It is responsible for transmitting individual bits from one node to the next node. When receiving data, this layer will get signal receiving and convert in ones and zeros. Send them into the data link layer, which we will put frame back together. Hubs, repeaters, modems, cables are physical layer device. Function of this layer, bit synchronization, bit rate control, physical topologies, transmission mode. Next, let's show how to work TCP/IP suite. TCP/IP standard for Transmission Control Protocol and Internet Protocol. The TCP/IP protocol is a condensed version of the OSI model. It contains 4 layers. These layers are application layer, transport layer, internet layer, and network access layer. Let's go to the first layer, presentation layer. Layer perform the function of the top of 3 layers of OSI model. Application, presentation and session layer. It's responsible for node-to-node communication control, user interface specification. Some of the protocol present in layers are HTTP, FTP, Telnet, etc. The next layer is transport layer. This layer analog to transport layer of OSI model. This is responsible for end-to-end communication error-free delivery of data. This shields the upper layer application of the complexity of data. The two main protocols present in this layer. Transmission protocol TCP is known to provide the reliable of error-free communication between systems. It performs sequence and segment of data. User diagram protocol UDP, on the other hand, does not provide any such feature. It is the go-to protocol if your application doesn't require reliable transport and is very cost-effective. Unlike TCP, which is a Connection-oriented protocol (UDP) is connectionless. The next layer is Internet layer. This layer parallel is function of OSI layer, network layer. It defines the protocols which are responsible for logical transmission of data over the entire network. The main protocols residing in this layer are IP, Standard of Internet Protocol, and it's responsible for delivering packets for the source host to the destination by looking at the IP address in the packet of header. IP has two versions. Those are IPv4 and IPv6. The last layer of TCP/IP model is Network Access Layer. This layer corresponding to combination of data link layer and physical layer of OSI model. It is lookout of hardware addressing, and the protocol present in the layer allows for the physical transmission of data. We just talk about APR beyond the protocol net layer, but there is a conflict about declaring its protocol of internet layer or network access layer. It is described as residing in layer 3, being encapsulated by layer 2 protocols. This topic is relationship between OSI 7 layers and TCP/IP suite. As shown in the diagram, the TCP/IP model has 4 layers, while the OSI model consists of 7 layers. Diagrammatically, it's looked that the 4 layers of TCP model exactly fit the 7 layers of OSI model, but this is not reality. The application layer of TCP/IP model mapped to the first 3 layers of OSI model. The transport layer of TCP model directly to the transport layer of OSI model. The internet layer of TCP model mapped directly to the network layer of OSI model. The last two layers of the OSI model map to the network layer of TCP model. TCP/IP is the most widely used model as compared to the OSI model for providing communication between computers over the internet. The next topic we are discussing: what are the analog signals, what is a digital signal, what are the signal amplitude, frequency and phase, and what is the bandwidth. Okay, let's go to the first topic. What is an analog signal? Analog signal is a continuous signal in which one time vary quantity representing another time-based variable. This kind of signal works with physical value and natural phenomena such as earthquake, frequency, wind, weight, light, and etc. The next topic is what is the digital signal? A digital signal is signal that is used to represent the data sequence of separate value at any point in time. It can only take one of the fixed number of values. This type of signal represents the real number within consistent range of values. Next topic is what are the signal amplitude, frequency and phase. Amplitude specify the maximum distance between the horizontal axis and the vertical portion of the waveform. Frequency tell us how to quickly sine wave complete full cycle. This important characteristic influence the maximum rate at which analog signal can transmit information and determine how to analog signal will be affected by circuits and include capacitors and inductors. Phase refer to the horizontal portion of waveform containing one cycle. It is easier to understand the context of phase shift or phase difference. We use this term when describing the extent to which one signal and shift to the left or right relative to another signal or theoretical reference signal. The next topic is what is bandwidth? Bandwidth. Bandwidth describes the maximum rate transfer rate of network or internet connection. It is measure how much data can be sent over the specific connection in the given amount of time. For example, gigabit internet connection has bandwidth 1 to 5 megabytes per second. The bandwidth used to describe the network speed. It does not measure how fast bits of data move from the one location to another. Since data packets travel over the electronic or fiber optical cable, the speed of each bit transfer is negligible. Instead, bandwidth measures how much data can flow through the specific connection at one time. The next topic series are: what are the difference between data words and code words, how to detect error from block coding, how to correct error from block coding. The first topic is: what is the difference between data word and code word. In block coding, we divide our message into blocks. Each block of k bits, called data words, we are R redundant bits are each block code make length n plus kr. The resulting n blocks are called code word. How to this? The next topic is how to detect error from block coding. The sender creates code word out of data word by using the generator that applies the rules and producer of encoding. Each code word send the receiver may change during the transmission. If the receiver code word is same or as one of the valid code words, the word accepted. The corresponding data word extracted for use. If the receiver code word is not valid, it is discarded. However, if code word is corrupted during the transmission but its receiver word still matches a valid code word, the error remains undetected. The next topic is what are the signal amplitude, frequency and phase. Amplitude: specify the maximum distance between the horizontal axis and the vertical position of the waveform. Frequency: tell us how quickly sine wave complete full circle. This important characteristic influence the maximum rate at which analog signal can transmit inform and determine how analog signal will be affected by circuit that include capacitor and inductors. Phase: the phase refers to the horizontal position of the waveform concerning one circle. If it is easier to understand in the context of phase shift or phase difference, we use this term when describing the extent to which one signal is shifted to the left or right relevant to the another signal or theoretically reference signal. The next topic is: what is bandwidth? Bandwidth describes the maximum data transfer rate of network or internet connection. It measures how much data can be transferred over the specific connection in given amount of time. For example, a gigabyte Ethernet connection had bandwidth 125 megabytes per second. The bandwidth is used to describe network speed. It does not measure how fast bit of data move from the one location to another. Since data packets travel over the electronic or fiber optical cable, the speed of each bit transfer is negligible. Indeed, bandwidth measures how much data flows through the specific connection at one time. The next topic series are: uh, what is the difference between the data words and code words, how to detect error from block coding, how to correct error from block coding, and what are the receive buffer and transmit buffer. The first topic is: what are the difference between data and code work. In block coding, we divide our message into block code. Each of bit k, called the data words. We add R redundant bit to each block code to make the length n equal k plus R. The resulting n block codes are called code words. This is I include the example how to calculate code words, and data words. The next topic is how to detect error from block coding. The sender creates code word out of the data words by using the generator that apply the rules and producer of encoding. Each encode send the receive may be changed during transmission. If the receiver code word is same as one of the valid code words, the word is accepted. The word corresponding the data word is extract for use. If the receiver code word is not valid, it is discarded. However, if the code word is corrupted during the transmission, but the receiver word is still matching is a valid code word, the error remains undetected. Here include some examples for how to detect block coding, and we are going to next topic, how to correct error from block coding. The error detection is process of the detecting errors. The receiver need to know only that the error receiver code word is invalid. In error detections, the receiver need to find or guess the original code words, and we can say that we need more redundant bits for error correction than the error detection. The error present in data transmitted from transmit to receiver. In communication system, we use some redundancy code to detect those errors by adding to the data while the transmit from source transmitter. The codes are called error detecting codes. Types for error detections are parity checking, cycle redundancy checking, longitudinal redundancy checking, checksum. The next topic is what the receive buffer and transmit buffer. Receive buffer. The buffer is the system memory that can be used to the adapted for the receiving packets, which can be increased to the help improve the performance of outgoing network traffic, but it consumes the system memory. Next is what is the transmit buffer? The buffer size of system memory that can be used by the adapter for sending packet, which can be increased to help improve the performance of outgoing network traffic, but consuming system memory. Thank you.